Hello and welcome. This is going to be the first in a series of video tutorials that walk you through the different aspects of APP. This video will show you the basics of setting up an aircraft file. So upon opening up APP, you'll see a welcome menu that gives you the option to create a new file or open an existing one. I'm going to open an existing one because I already created this one, but you guys will go ahead and hit new. And what you'll see is general aircraft information that you're going to fill in as needed. I'm just going to put in some generic information and go from there. And down below we've got a comment section. This can be used for general comments about the aircraft file, but it also can be used for revision control.
So next is going to be mass and limits. We're going to create a new mass and limits configuration by hitting add. We'll keep the default name clean. And then before I go any further, note the tabs across the top of this page. We're going to work our way from left to right down these tabs, and then within each tab we'll go down the line.
So the structure mass is 1,001 kilos, and from propulsion group all the way down to ammunition is going to be 0 kilos. And the payload mass is going to be 248 kilos, with the fuel mass being 151. And we can keep the propulsion group all the way to the ammunition group masses as 0 because APP performs what's called a point performance computation. So these individual masses aren't necessary for what we're trying to do.
So we're going to go ahead and move on to battery. Now, we're not actually going to be using a battery in this example, but if you guys are running an electric propulsion system, this is where you would add the battery mass. And the battery mass can be calculated by using a combination of the battery and specific energy, or you can just set it manually. So on to engine. The number of engines is going to remain at 1. The thrust line angle will remain at 0. And thrust multiplier and fuel flow multiplier will also remain at 1.
On to aero. The delta drag area and drag multiplier are going to be the same, 0 and 1. I'm going to move on to gear. The gear drag area is also going to remain at 0. Angle back on the ground is also 0. And you can see we can add a fixed gear down at the bottom if we wanted to, but we're not going to. On to mass limits. Now we've got a positive limit load factor and a negative limit load factor. We're going to go ahead and make those 4.4 and negative 2.2 respectively. And then similarly, we got the maximum AOA and minimum AOA. We're going to make those 45 and negative 10. And I should note that the angle of attack set here is not actually the stall angle of attack. It's more the bound or the computation area of the point performance. Mach limiter and AOA-G limiter aren't necessary because it's a low subsonic vehicle. And this would probably be a good time to notice the description sheet and chart tabs. These are pretty standard on all of the fields that we're going to be populating today. The sheet just shows the data we just put in an Excel style format, and you can actually export it to Excel if you wanted to. Chart is legitimately just plotting the data that we added to this field.
Okay, so we're going to go ahead and move on to aerodynamics now. Notice it is the same as mass and limits. Going to select add, and we're going to create a cruise configuration. I'm going to go ahead and stop it here. Note the data, CDO, DCL, CDI, CL, and CLMX tabs. We're going to go ahead and go through all of those. And then also notice the same description sheet and chart tabs as the mass and limits section. So the data tab has aspect ratio, which is going to be 7.7, and a reference area of 14 square meters. Off to CDO, which is going to take it in tabular form. We're going to add a table that's going to be a function of altitude. Note that it is in meters But if you wanted to change the default units, you can come down to this drop down and select SI or British. Since the data I have is in meters, I'm going to go ahead and use meters for now. And it is going to be a function of, CDO is going to be a function of Mach, and that's going to be 0.0198 at a Mach of 0.3.
Next is DCL. DCL lets you enter the vertical displacement of your drag polar. So if the curve of your entered induced drag goes through 0, the CDL values correspond to the lift at minimum drag. However, if your induced drag polar already includes that vertical shift, you can set DCL to 0. If you're unsure of if it's right or not, you can go ahead and switch over to the Charts tab and double check your chart. CDI is similar to CDO in that it is indexed by Mach in a table, and we'll select 0 for this table.
And CDI is a function of CDL, and I'm going to go ahead and copy this table in there. Like so. And you can do this from a Excel spreadsheet. So you can copy and paste Excel sheets into the tables if that is the form your data is coming in. All right, on to CL, which is another table as a function of Mach, and CL is also a function of angle of attack. So I'm going to copy that data in there and jump on over to CL max, where CL max is just 1.3 at a Mach of 0.3. And of course the description sheet and chart tabs that are common in all of these groups.
And let me just add one more thing in regards to aerodynamics. If you have different flap settings, you will have to create a new aerodynamic set for those flap settings. So if you have 50% flaps, then you'll have to model that in Aero in addition to clean or 100% flaps, etc.
All right, propulsion is next. Same as the others, we're going to select add, and then you'll have a pop-up that gives you a choice between a conventional propulsion or a electric propulsion. Since we're running a single piston engine, we're going to go ahead and do a prop, which is a fixed pitch or constant speed prop, turbo shaft, or piston engine. And we're going to go ahead and name it 300 horsepower engine. When you hit OK, first thing that you'll see is a manufacturer and a variant for your engine. We're going to go ahead and populate those. But what also comes up is a thrust characteristic and fuel flow, which are going to be series of tables just like the others that we're going to have to add. You can also import existing thrust characteristics or fuel flow from other aircraft files, but we're going to go ahead and add this manually. So note the same tabular format. We've got propeller, CP, CT, max shaft power, min shaft power, etc. And then the standard description sheet and chart tabs. So propeller diameter is going to be 1.9 meters. Gear ratio will stay at 1. Max RPM will be 2400. Min RPM will be 0. You have the option to have a fixed propeller, but we're going to have a prop beta range of 0 to 45 degrees. So CP, notice how it's the same in that we are going to be adding data via a table, but we're going to be adding subtables to those tables. So the first table will be a Mach, and we're going to go make it 0.3. And then we're going to add a subtable that's going to be indexed by beta angle. And these subtables are going to be incremented by 5 degrees all the way up to the beta limit, and we're going to provide CP as a function of advance ratio. So I'm going to go ahead and speed this up because this is going to take a minute. You guys pause as needed and add in your data along with me. And what this is a 3D lookup table where the dimensions are Mach, propeller beta, and advance ratio. And what APP does is interpolates between the cracks of these tables to get the correct CP for a given set of inputs. And you can change this interpolation type down at the bottom here. And the two provided interpolation types are linear and cubic spline. So CT is going to be virtually the same layout. We're going to add a table that is indexed by Mach. We're going to add a subtable that's indexed by beta angle. And we're going to hit OK. And then CT is going to come in as a function of advance ratio. And I'm going to do the same thing as I did before. I'm going to copy these in from the entire span of beta, 0 to 45 degrees. And then I'm going to go ahead and speed through this, and you guys can stop and go as needed.
So next is max shaft power, but before I go any further, I want you guys to switch your units designation to 1 up in the toolbar. Notice the 1 through 4 up by the save button. 2 is the default of APP, but I only have max shaft power data in British units. So go ahead and flip that to 1 and go ahead and add a table. And it's going to be an 1800 RPM table. And the subtable will be by altitude. And we'll go ahead and do sea level, 0 feet for now. And this is going to give us max shaft power as a function of velocity and knots.
So the subtables will span 20,000 feet, increments in 5,000 feet, and the tables will increment by 100 RPM and span 1,800 to 2,700 RPM.
So I'm going to go ahead and speed this up again so you don't have to watch every single entry. Next is going to be minimum shaft power. This is going to be all zeros, mainly because APP just needs something to interpolate against. We need 2 bounds, so we're going to add in zeros for all this. Next is exhaust jet thrust. It's a piston engine. There's no jet, so it's going to be the same as minimum shaft power, and we're just going to populate it with zeros. And the next tab is the fuel flow file. We're going to come back to it because this is where we're going to assign a fuel flow for a thrust characteristic for this engine selection. So we need to create a fuel flow. So we're going to go ahead and enter in prop fuel. And this is going to be a simple 1 table at sea level. It is indexed by velocity. And we're going to change the fuel flow with respect to shaft power. Going to copy it in. And boom. So now we're going to assign this fuel flow to the previously created thrust characteristic.
All right. Next in the list here is stores. We're not actually going to do an example of this, but I just wanted to show you guys how it would look if we created a drag store. And a drag store is just an additional payload, external tank, a weapon, etc. It can be removable, and it allows us to add in all of the pertinent information for an additional payload. And last is the aircraft configuration. And an aircraft configuration is legitimately the culmination of all of the pieces, parts that we've been creating here. To create the aircraft configuration, you'll just hit add. We'll call this one clean cruise. Mass and limits is clean. Aerodynamic is cruise. Propulsion is our 300 horsepower engine we created. The rating will be cruise prop. And hit OK. and you can see that our configuration has been created. And the stores down below, if needed, you can just create a new one and then add a store loadout. And you can see the small lowercase test that I had created as an example before. So if you wanted to create a store loadout for this configuration, you can do that. But we're not gonna do that, so we're gonna remove that and save it.
And this is a really important step to make sure you've got your configurations right, because this is where all the aircraft configurations are going to live. Gear down, gear up, flaps down, flaps up, etc. So if any of the output doesn't look like it should, this is where I would start and then work my way up. So that about does it for aircraft files. Go ahead and make sure you save the file before you leave. But other than that, I'll see you all in the next video.